All right, f is continuous. The limit is infinity as x approaches infinity of f. And for f prime, the limit is 3 when x approaches infinity. So find the limit when f of x is raised to this power. Let's let y equal this function. So if we're finding the limit of that function, then we're finding the limit of y. And now we'll just look at the equation y equals this function. And as we've seen many times before, we'll take the natural log of both sides, apply that property of logs, and now we'll take the limit of both sides. And when we do that on the right, as x approaches infinity, this first factor approaches 0, and the second factor approaches infinity. Because f of x approaches infinity, and the natural log of f of x, this is the second factor, will therefore be approaching infinity. So we have a 0 times infinity indeterminate form, so we can't apply L'Hopital's rule unless it's a ratio. So we'll write the 1 over x in the denominator. Multiplying by 1 over x is the exact same thing as dividing by x. And now we have the indeterminate form. As x approaches infinity, our numerator is approaching infinity, and our denominator is also approaching infinity, and so we can apply L'Hopital's rule. In general, we're going to be able to evaluate the right side, and once we do, we'll be able to evaluate this side, and we'll then know what the limit of y is as x approaches infinity, which is exactly what they asked us to find. So let's continue here using L'Hopital's rule. The derivative of the natural log is 1 over, and then the chain rule, so times f prime of x. And the derivative of the denominator is just 1. So we're left with just this product. And guess what? That's exactly what they gave us in the beginning. The limit as x approaches infinity of f of x is infinity. The limit as x approaches infinity of f prime of x is 3. So we have 3 over infinity, and 3 over infinity is approaching 0. So we have the left side is equal to 0. Next, we're going to solve for y. Exponentiate both sides. And using properties, a base raised to a power of a limit of something is algebraically equivalent to the limit of that base raised to that something. And e raised to the ln of y is just y. So we have the limit as x approaches infinity of just y is equal to 1. And that's what we're looking for, the limit as x approaches infinity of y. Because we let y equal to this. So we have found exactly what they asked us for. The answer is 1, which was choice B. There you go.